going to do a few more examples on this work because it needs a lot of practice. Alright, so the first question here is a hiking group walks from White Beach to Top Ridge, a distance of 20.8 kilometres in the direction 76 degrees. Right, so we're going to get the direction first. So we start with a compass rose, start from north and go clockwise through 76 degrees, which will be in here somewhere because it's not going to go as far as 90. So let's do that first. So it's 76 degrees to get to that point there. Then off we go for a distance of 20.8 kilometres. Okay, go a little bit further, I think. All right. Now, it then says they then turn. So here they are now. They've already walked from here to here. They then turn and hike due south. That means directly south. So we're going straight down. Now, you could actually draw up a compass rose here because we are starting the second leg of our journey, but then you would just be going straight down south, so I'm not going to worry about it, but you can draw a compass rose up there if you like. So we're going due south to Riverwood, then due west back to White Beach. Okay, so we started at White Beach, WB, we went to Top Ridge, TR, then we're hiking back south, and then we're going to go due west and head back to there. So what we're doing is this. Alright, so we went south, then west, and we ended up back where we started. This place was Riverwood, so we just call that R. Alright, and that's your diagram so far. Now the question says, how far have they hiked all together? So look at what they've done. They've gone there, there, there. So you have to find all three sides of that triangle and add them up. Okay, so let's have a look. We have not got an angle inside this triangle to use at this stage. Okay, so it's really important we end up with one of these angles. And this one's closer to the 76, so it's easier if we find that one. So to find that angle there, we would do 90 for that whole right angle. Take away the 76. And that will leave us with 14 degrees. I'm going to put that in there now. So anything you're kind of adding to a diagram, I'm just going to put in red. All right, so now we're going to find this bit here, which I'm going to call X. So we're going to find that length. All right, so if you have a look at your triangle now and label your sides, this is your opposite side to the angle that you've got, and this is your hypotenuse. So we're going to use sine. So sine theta equals O over H. Sine 14 degrees equals X over 20.8. Now we're going to get the X by itself by getting rid of the divided by 20.8. Take it to the other side and times by it. Then use your calculator and you'll get that answer. I'm not rounding anything off yet because we haven't finished. Now the next thing we're going to do, and I might change colours here, we're going to find this side. And I'm going to call that Y. Alright, call that one Y. And if we label the sides with the blue pen now, this one is the adjacent side. You've got your hypotenuse again over here. So we're going to use cos. Cos theta equals A over H. Cos 14 degrees equals Y over 20.8. And then we're going to get rid of the divided by 20.8. Go to the other side and times by it. And then use your calculator. No rounding. Okay, now we're going to add up our sides. So we're going to add up this side, and that side that we already knew. We're going to add the three sides of the triangle up. That's what it's going to give you when you've done that. And now we're going to round to 0.1 kilometres, which means we only want one decimal place. So if we round off to one decimal place, it will end up being 46.0, and it's kilometres on the end. Okay, so show every step of this working. Nice big clear diagrams. Be prepared to use different colours because you're going to get confused if you don't. Okay, next question, number 4. A plane takes off from Broome at 10:15 AM and flies on a bearing of 150 degrees. We're going to draw our diagram straight away, north, south, east, west. Just put them on the bearing of 150 first. Go past the 90 and we'll be in here. So there's B for Broome. The plane has travelled along here and there it is at the moment. And it travels at 700 kilometres per hour. Now that is a speed. Don't write the speed on that line. That's for distances. That would be the length of the line we're looking for, the distance. So at the moment, we've got times and speeds. We have no distance. So I have taught you this triangle before. Make sure you learn it. It's really helpful. So we're looking for the distance at the moment. So I'm going to circle D for distance in this diagram. So D equals S times T. So write your formula down. The plane travels at 700 kilometres per hour. That's the speed. Now, how many hours does it travel for? Well, it started at 10:15 a.m. and we're going to 1:45 p.m. So if you work that out, that is 3.5 hours. So 3.5 hours or 3.5 hours, however you want to write it. If you multiply those numbers, you'll get 2,450 kilometres. Okay, just make sure these units here are the same, which they are, so we're fine. So the distance the plane travelled was 2,450 kilometres. You can write that on because you've got a distance now. Okay, now the question in part A says, how far south are we at that time? Okay, so this is all we've got for a diagram, so we've got to form our right angle triangle. So the easiest way to do it, remember, is either to go straight up or straight across to the line of the compass rose and form your triangle. Okay, I might go this way. You can go up, it doesn't matter, whichever way you want. Now we've got a right angle triangle. Okay, now it says we are finding how far south. So north-south is a vertical line. So we're looking for the vertical line in this triangle. So I'm going to call that X. And that's what we're looking for. All right, so let's have a look at what we've got. I'm going to find this angle here. And if you think about it, you've got 180 degrees from north to south. This is 150. So this will be 180 take away 150, which will be 30 degrees. So I've got a 30-degree angle there. So if I label my sides now, this is the adjacent side, and this is the hypotenuse. So we can use cos. Cos theta equals A over H. Cos 30 degrees equals X over 2450. We're getting X by itself, so we're getting rid of the divided by 2450. Come over and times by it. Use your calculator and write your answer down. Now, we're not rounding at all in these questions unless they ask. They haven't asked, so that's it. That's your answer. Okay, next one. Part B is asking for the bearing of Broome from the plane. So that means the plane must be in the middle of the compass. So let's have a look. Is the plane in the middle of the compass? No. So we have to draw up a new compass with the plane in the middle. I'm using a different colour so I don't get too confused. All right, now we want the bearing of Broome from the plane. So we're looking for this angle here for our bearing, north clockwise till we hit the line. That's what we're after. All right, so to get it, we can't get that bearing unless we know this little angle in the corner of this triangle here, the red one. So if you think about it, that was 30. That one will be 90 minus 30, won't it? All right, so that little blue bit, come out here, will be 90 take away 30, 60 degrees. So the bearing itself is pretty easy to do then because you're just going all the way around to west would be 270 plus that 60 on. Now if we add those together, you get 330 degrees and that's your bearing. Okay, number 5, we've got 2 ships leave from the same port. They should have said at the same time, they didn't, but that's what they mean. One ship travels on a bearing of 157 degrees at 20 knots. Now down the bottom they've explained what a knot is. Those of you that have anything to do with boats or the water will know what a knot is, but most people don't. A knot is 1 nautical mile per hour. Okay, so it is a speed. All right, so we're going to start to draw this diagram. So the first ship is travelling on a bearing of 157 degrees. So that's what I've done over here. Here's my compass rose. From 157, start from north, go clockwise. 157, you'll end up in here and draw out. Okay, so that's the first plane. I'm calling it A because the numbers will just get mixed up if I call it ship 1. All right, so we're going to call it ship A. All right, so that's what the first ship does. Now, I can't write that distance on until I find it. Okay, so remember, they've given us a speed. They said it's travelled for at a speed of 20 knots. And it tells you down here that they travelled for 8 hours. So if we draw up our triangle again, we're finding distance. Distance equals speed times time. Write your formula down. So it's 20 knots, which is the same as 20 nautical miles per hour. The symbol for nautical miles is a capital M. Okay, but it doesn't matter if you don't know that. Just write 20 knots if you like. But 20 nautical miles per hour. The only reason I'm writing it like this is because that's per hour. This has to be in hours, which it is. Okay, so 20 times 8 gives us 160 nautical miles that the first ship was travelling for. So I'm going to write that on, 160 nautical miles, that's what it was doing. Now the second ship travels on a bearing of 247 degrees. So if we start with the same port, 247 will take you past the 180, not as far as the 270, so it's going to be in here. And I've marked it in with the blue bit, that's 247 degrees. So this is the second ship, ship B. Now it was travelling at 35 knots. So 35 knots is 35 nautical miles per hour, still travelling for 8 hours. And we work out that ship travelled for 280 nautical miles, and we'll write it on. Okay, so now we've got the two distances on the triangle. We can read what the rest of the question says. And it says, how far apart are those two ships? Well, here they are. And we're looking for how far apart they are. Okay, so we're looking for this line here. Now, if you go back up to these bearings, 157 to get to there, 247 to get to there, what is this gap here? Well, if you do 247 minus 157, you'll find out that that's a right angle. It's 90 degrees, which means we have a right angle, and we have a right angle triangle now. So that red line that we're looking for is the hypotenuse, and we've got two sides in the triangle already. So I'm going to use Pythagoras' theorem to find that hypotenuse C. So we start off with Pythagoras' theorem, c squared equals a squared plus b squared. C squared equals 160 squared plus 280 squared. That will give us 104,000. And now we'll just move over here a little bit so we can see the rest of this. Because these questions aren't easy, we just need to work through them. Okay. Alright, so if you have a look at what's happening now, if we square root that number there, we'll end up with our hypotenuse, and we are rounding for this question to the nearest nautical mile. So we're rounding off to the nearest whole number. Okay, now in part B says calculate the bearing of the second ship from the first. So the first ship needs to be in the middle of the compass. Let's have a look and see if the first ship is in the middle of the compass. That was ship A. No, it's not in the middle of the compass, so we need to draw a compass up around there so that that is in the middle. Okay, so what they're asking for is the bearing of the second ship from the first. Okay, so we're going to go around here and to the line that's taking us off to the second ship. If we can get that, we've got our bearing. All right, so that's what we're after. All right, so let's have a look over here. What I've drawn is the right angle triangle that we were looking at. I've put everything in. Now, why am I looking for this angle here? Why have I decided to try and find that? Well, the main reason is that that is very close to what I'm trying to find here with this bearing. So you're looking for the angle in the triangle that's closest to it. I'm not going to look for this one over here, it's got nothing to do with it. This one here that's really close to it. So even if you don't know how to get the bearing out at the end of this question, it's really important that you find that angle because you'll get some marks. Okay, so we're going to just come over here to our triangle that I've just redrawn separately because it's a bit messy over here now. And we're going to find that angle theta. So it's opposite over adjacent, so we're using tan. So tan theta equals O over A. So tan theta equals 280 over 160. We know we have to get rid of tan so that theta is by itself. So come over here and do the opposite operation, which is inverse tan. So theta equals inverse tan of 280 on 160. And if you go to your calculator, do that and make sure you press the degrees, minutes, seconds button. You will have degrees, minutes and seconds. Remember that you're looking at the seconds, and if that's less than 30, the minutes will stay. If the seconds is 30 or more, the minutes will go up by 1, and that's the answer you should end up with when it's to the nearest minute. Okay, now we've still got to find this actual bearing here. So I've drawn just what we need to be looking at. So what I've got, the angle that we just found is this one. 60 degrees, 15 minutes. That's the angle inside the triangle. All right, I'm trying to find the bearing, which goes, just might put the north line in so you can see what we're doing. So I'm trying to find from north clockwise all the way around till we hit that line. That's what we're looking for. So there is something else that we have here, which I've written it in over there, but you may not be able to see it. So up here we have 157. Now, I do know what this angle in here is. Okay, if you think about it, I might just use the blue pen here. Right, so this angle here is 157 minus 90, which is 67 degrees. Okay, so you've got 157 coming all the way around to there, 90 only going to the east, so we have to do a subtraction to get that little angle in there. Now, if I've got that angle in there, I'll just see if I can draw it in over here so you can see where it's coming from. Yep, that's it, isn't it? Okay, so if we go, this bit here is 67. Then you should be able to then see that I have alternate angles here. It goes into the blue line there. Okay, so all of that, if you go looking at it, you've got an east line there and an east line there, they're parallel. So you've got 67 and 67. Their alternate angles are equal. All right, now, I know that angle in there in the triangle I just found was 60 degrees, 15 minutes. So if I do 67, take away the 60 degrees, 15 minutes, I'll end up with that little piece there that I've called theta in red. So I've done the subtraction, and that little bit works out to be 6 degrees, 45 minutes. So now my bearing, the red bit, will be 270 to get round to west, plus that little bit. So that's what I've done there, and that's the final answer for your bearing. So really practice these questions, okay? And as I said, do a diagram, do it really big. If it looks too messy, redraw parts of it like I've been doing so you can clearly see what you're doing, all right? And if there's any bit of working you can do, even if you don't get the whole thing out, then do what you can do, all right? You'll always get a few marks if you're on the right track, like finding this angle in here, for instance, all right? So show all you're working, and good luck with your homework. Let me know, email me for any questions you're having trouble with.